Hey everybody, this is Games Plus James, and welcome back to our Unity 2-player tutorial series. So we've got our little level all set up here for us to go with. The first thing we need to do now though is make our player be able to move around in the world. So at the moment he's just kind of floating there doing nothing. So let's start out by doing some things to him. So we got our little player up here. I'm going to drag him to the bottom of the list just so we can easily find him rather than being up here. And what we're going to do is give him a box collider, so he's a physical object in the world. We're going to add a box collider 2D. I already had it slightly typed in. And then we're going to add a rigid body 2D, like that. Actually, just remove that. I want to have the rigid body up a bit higher. So I'm going to say box collider 2D. There we go. So we've got a little box collider around our dude. If we just zoom in here, you can see we've got a little green outline around here, which is much bigger than our player, so that's no good for us. So we're going to adjust that a little bit. So we're going to drag the X value to the side, and that'll make that a little bit smaller. And it's a little bit too big, so we're going to drag it down a bit too, and then drag the offset so that it's actually touching the ground. What we'll actually do is to make sure that it's a specific exact number, we'll set the Y at 0.9 like that. And then the minus the offset Y here to minus 0.05. So we know it's exactly at the bottom there like that. Okay, so we've got our player. We've got a rigid body applied. So now if we press play, our player will, once it starts running, our player will fall down to the ground. But of course, the player isn't going anywhere at the moment. He's not really moving or anything like that. So I'm going to stop that. One other little thing before we actually give him movement, we want to make sure that if we go to constraints here, we want to freeze the rotation, because we don't want our player falling around all over the place when we move and spinning around in the world. That would be no good to us at all. So as I said, we have that all sorted out. So we're going to need to create a script to make our player be able to move in the world. So we'll go to our assets folder here. We're going to create a new folder for our scripts. And then we're going to take a new C# script and we're going to call it our player controller. And we're going to open this up in MonoDevelop. Okay, and once this is opened up, first thing we're going to need is to know how fast is our player going to move. So we're going to create a public float value. So our float is our number value. That we'll call move speed, so that'll be how fast our player can move within the world. And then we'll have a public float that we're going to call jump force, and that'll be obviously how much our player jumps up in the air. So to be able to move and jump, we're going to need to affect the rigid body, which is attached to our player, which is what's giving our player its gravity in the world and making it interact with physics. So we're going to have to make a reference to that in our script. So we'll have, actually not public, we'll have it be private rigid body 2D, that we'll just call it the RB, short for the rigid body. And then in our start function here, as soon as we start the game, we want this script, which will be attached to our player, to find the rigid body that's attached to the player as well. So we'll just say the rigid body is equal to get component rigid body 2D, like that. Okay, perfect. So now that we have our player and it's interacting with our rigid body, actually before we go any further, we're going to do something which is always a logical and sensible thing to do, which is as soon as you create a script and you know exactly where that script is going to go in your game, i.e. we know that this script is going to go onto our player. So the first thing we should do is grab this script and attach it to our player. So we can drag it into the add component here, or of course we can go add component and type in player controller if we wanted to. Okay, so now that we have that there, we have our values that we created for our move speed and our jump force. So I'm going to give him a move speed of 10 and a jump force, we're going to have it as 20 at the moment. We'll adjust those figures as we need to. But of course at the moment they won't do anything. If we hit play, all we've done is create two random values that don't actually do anything for us. We can press any buttons we want, nothing will happen. So if we go back to our script, the first thing we want to do is make our player be able to move left and right. So a normal kind of way you would do this in Unity would be to say if input dot get key, just get key, and we say we want it to be that we move left and right with the A and D keys. So we would say key code dot A. So that will be the button to move our player left, and then we'll write some code to make our player actually move. But what we want to do is something slightly different. Because we're using 2 players in our game, we don't want both of our players to be able to if we press A, we don't want both our players to be moving left the exact same. So what we're going to do is add custom controls for each different player. So I'm just going to delete this for the moment. We'll come back to that. What we're going to do up here, this is the most kind of basic way to add custom controls. It's not too complicated. Basically what we're going to do is create a public key code that we'll call left, public key code we'll call right. We'll also need one for jumping. So public key code jump. And then finally, when we get a little bit further, we'll have our player throwing snowballs. So we'll have another key entry for throwing our snowballs. So public key code throw ball. Now you can't just call it throw, because throw is another reserved word within Unity. So it'll mess up your code. So we want to call this throw ball, just for simplicity's sake. And if I just save this before we go and write any more code, we'll see how that actually looks in the editor. So this is how in your own game, however you want to set it up. It like I said, this is the idea. This is to be able to play this with some other people. So if you want to be able to use whatever custom controls you want, what you can do here is for left, okay, whatever we want our player to move left with, what we want to use is the A key. So if we press A, you'll see the first thing it does is it goes to ampersand here, but what it'll do is basically cycle through the A's in this list. So if we hit A again, we just keep hitting it a few times, and eventually we get to just our A key. And if we want to move right, we have that on the D key. So I went too far there. It'll just loop through and try to find the right thing. There we go, I got it right that time. So we can hit D like that, or of course you can just scroll through the list if you want. You just hit the little down button here. I clicked off by accident. So we have our left and our right set up. For our jump, we're going to set that on, say, our space bar. So we'll type in space, or no, that doesn't work. We'll just hit S to cycle through the S words, and we should hit space. There we go, up the very top here. And then finally for throw, I'm going to set this as F, just for this character. So that's fine. So those will be the keys that we use. But equally, I just want to show that if you wanted to have it so that this worked with a controller plugged into your computer, we could go for, say, for our throw ball here, we could use joystick. So if we go to the J's, we've got joystick button, and rather than explaining what all these buttons do, it's probably easier to just look up what are the controller layouts on for Unity. But I believe button 0 is the A jump button and stuff like that. So you can use these various different buttons to configure a controller if you want to as well. But we'll just stick to using the keyboard for now. So now we have our setup just the way we want to. So let's go back in here and actually make our player move. So we'll say if our player wants to move left. So we'll say if input dot get key, so that checks is the key currently being pressed, and rather than saying key code dot A, all we have to say here is left, because left is the key code up here that we created. So if we are getting input from the left key, then we want to make our rigid body move to the left. So we'll say the rigid body dot velocity, which is the speed of the rigid body is moving, is equal to a new vector 2. So vector 2 being just an item that has 2 number values, that has an x and a y value. So if we want to move along the x-axis to the left, we need to go in the minus numbers on the x-axis. So we want to get our move speed and move at minus move speed. So we'll say minus move speed, and on the y-axis, we say our player is jumping or anything like that, we don't want to affect that, so we'll just take whatever is currently in the rigid body's velocity. So the rigid body dot velocity dot y, like that. And that's basically all we need to do to move our character in the world like that. So if we're moving left, then we know what this is happening. But if we're not pressing the left key, then we have a couple of other options. We could be moving to the right. So we'll say else if input dot get key, like this, and is right. Oh, I need to close that bracket. So if that's happening, then we want to do almost the exact same code. So we can just copy this line here, copy it, paste it in, and take off the minus on the move speed, so we can save that. And now our character will either move left or right depending on what we press. So let's see how that works in the game before we do anything else. We go back in here, let that compile for a second. On our player, make sure everything's okay over here. And now if you play the game, we'll see we can move right, we can move left, but I'm only tapping left and right here. You'll see our player continues moving after we press it, and that's not really what we want. We could make it a feature as that's our player kind of sliding around on this snowy ground, but it doesn't make it fun to play. So what we'll do is add a new statement here. We'll say else if again. Oh no, we won't say if, sorry, we'll just say else. So basically, if we're not inputting left or inputting right, then we should have our player not moving on the x-axis at all. So we'll say here, again, we'll just copy this line of code like this, but instead of applying any move speed left or right, we'll just say 0. So it stops moving as soon as we let go of one of those keys. So we'll see that here now. Let it compile again, and then we'll hit play. Now this is a very simple way of applying our code, of applying our movement code. But we can see now if we just tap, we stop moving like that. But at the moment, the way it's set up as well, for example, if we're holding left and then press right, our player keeps moving right. But if we're holding right and then tap left, our player goes back to moving left. So if we're holding two keys down for left and right, our player will always move left. But the chances of anyone doing that at any particular time are quite slim, because why would you do that? But just know that this is a slight little quirk of this simple way of moving our player around in the world. Okay, so we have our movement left and right, so let's give it some movement to jump up in the air. So if input.getKey, instead of just using getKey, we're going to use getKey down. So that checks if the button was just pressed right now. So if the button is just pressed and not being held down, then we're going to add some force to make our player jump up in the air. So what we'll do is you just use the jump key that we created up above, and then here we're going to copy this line of code again and make a slight change to it. So instead of now moving on the x-axis, we don't want to affect the x-axis this time. So we'll copy the rigid body dot velocity dot y, paste that in here, chop off the y and replace that with x. And now on the y-axis, because we're making our player jump, we want to add the jump force that we created up here. So we'll say jump force like that, and we'll save this and go take a look at this back in the game. Again, we let it compile. You know it's compiling if you don't already know. When this little thing is spinning down in the corner, we'll hit play, and now you can see we're jumping, but we're jumping really high and falling really slow. And now the reason for this is because just the way the gravity is set up on our player. So if we stop that running, go back to our player, go to our rigid body, and I'm going to change the gravity scale to be 5. And this is a balance that I kind of have come to that works well for me. But if we jump like that, we can see now we kind of jump up just one little layer like this. Our player kind of falls at a reasonable speed, and it makes it all kind of just feel a little bit nicer. So that's having our gravity on 5 and our jump force on 20. Now if we were to say change the jump force to 10, we'll see we haven't got quite the strength to be able to make it up on our platforms, but we'll still fall at the same speed. So it's about kind of finding that balance. You might like it more if we increase the gravity scale a bit and maybe increase the jump force. Oh no, that's too much jump force there. Say 20, still not enough. It's about finding this balance between these things. So there we go. Now what's happening with the increased gravity, our player falls faster after they jump. So it's kind of almost like they're slamming to the ground a little bit. But again, it's all down to what your personal preference is and how you feel about the game. So now, if I actually just restart this again, our player is able to jump, but there's one little thing which is not very helpful. Our player can just keep jumping like crazy whenever they want. So what we're going to add very simply is a check to see if the player is on the ground at any particular time. So if the player is on the ground, then we're not able to jump. So what we'll do for that is we're going to add we're just going to create an empty object as a child of the player, and we'll just call this the ground check, just to keep it nice and simple. And then we're going to move this so that it is at the bottom of the player's feet here. This is the same system we've used in other videos here on the channel in the past, but we'll go through it very quickly as we're going here. So we have a little ground check object, and basically all we're going to do is write some code that will draw a little circle around this, and it will check and see, okay, is there anything around this inside this little circle that is the ground? And if there is, then we'll check, then we know that we're on the ground, so we're able to jump if we want to. So let's go back into our player controller code. We're going to need to make a reference to this ground checked object. So we're going to say public transform ground check point, we'll call it. And then we obviously need to know if our player is actually on the ground or not. So we're going to create a public bool that we'll call is grounded. So that bool being something which is either true or false. So it's either true or false if our player is grounded on the ground. Like I said, we're going to draw a little circle, not draw it physically, but kind of an invisible circle. So we need to know the radius of that circle. So public float ground check radius, and then finally we need to know what is actually ground. What is our player going to be able to check and see if it's standing on? Because we say if this is at the bottom of our player's feet, but if that circle overlaps with the player himself, then it'll always be true if it's just checking to see if there's anything in the box. But we want to specifically check if there's anything that is the ground. So we'll say a public layer mask that we'll call what is ground, and we'll set that back up in Unity just after we write this bit of code. So the first thing we want to do is basically just at the start of our update loop check if the player is on the ground. So we can say our is grounded bool. So we're going to be setting this to be either true or false. And the way we can do that is we do a physics 2D, because we're doing everything in 2D, physics 2D dot overlap circle. So this is how we draw the little circle. So to draw the little circle, we need a point in space of where the circle is, and our point in space will be our ground check point dot position. So the position of the ground check point. We need to know how big the circle should be, and that is our ground check radius. And then we need to know what it is that we're looking for, which will be our what is ground layer mask that we create. So that's all we need, and basically that'll do, as I said, it'll draw a circle and check if the ground is within the circle. If it is, it'll say is grounded is true, and if it's not, it'll say is grounded is false. And so then all we have to do when we're pressing our jump key down, we want to add in a little bit to this if statement to say if we press the jump button and is grounded is true. So that's all we're checking. If is grounded is true, then we know we're allowed to jump, and we can go flying through the air all to our heart's content. So save that, pop back into the game, and then we're going to need to quickly set up what is actually the ground. So we'll let that compile. And we of course need to hook up the little stuff that we just created. So we create a space for our ground checkpoint, so let's drag that into there. We're going to set our radius to be 0.2, and then what is ground here At the moment it's set to be nothing. So what we're going to set it to is actually to just be default. So at the moment, when we create anything in our game, it automatically gets applied the default layer. So if I scroll up here, we can see our player is on the default layer. These little background things are default layer, although they don't have a physical thing in the world, so they won't count as grounded. But our platforms are on the default layer. Our background is on the default layer. Everything is on the default layer basically. So what we want to do is we want our player to be able to jump on anything that's physical within the world. So we're going to make it so that our player checks for the default, for anything that is the default layer, that's the ground. But of course our player himself is also default. So what we're going to do is on the layers here, we're going to click on default and we're going to go to add a layer, and we're going to add a new layer for player. Go back to the player here and set him to be on the player layer. Just like that. And now if we hit play, what we should get is player drops down, we can jump, but we can only jump once. Like that. So we can jump over here just the way we want, and we can jump over here like this, jumping around like crazy. So there you go. So now our player is able to move around within the world. Of course, at the moment though, he's this very static looking guy. He just kind of looks like he's sliding around. He's not really doing anything. So what we're going to do in the next episode is take a look at animating our player and make him look a bit more active and interesting within our world. So thanks for watching, and I will be back soon with some more Unity tutorial goodness.